All right, so this one's number 9. It says the given amount of annual interest is earned from a total of $10,000 invested at 2 funds paying simple interest. Write and solve the system of equation to find the amount invested at each rate. So the 2.6 would be my x, the 4.5 would be the y. The total amount invested is 10,000. So x plus y equals 10,000. And then 2.6% is 0.026x. And 4.5% 0.045y equals 355. So then to move this, you have to go 3 times or 1,000. So this becomes 26x plus 45y equals 355,000, 355,000. So then which one did you solve for the first one? Y. So y equals 10,000 minus x, right? So 26, oh, that's a bad color. 26x plus 45 times, this whole thing's going to get plugged in. 10,000 minus x. Distribute here. Combine your like terms. Subtract the 45. And then divide that by negative 19. And x is 5,000. So then it's because it's 10,000, they would both be the same, right? So y would equal 10,000 minus the 5,000. And then the y is also 5,000. It's hard to see, sorry. Good? Yeah. 4. All right, so this one says solve using substitution and then check your solution graphically. So they're already both solved for y. Like you don't have to isolate it. That y is already isolated. So you can take and either set this one here, or I could do the reverse. But either way, you'd get x squared minus 3x plus 1 equals x to the third minus 3x squared plus 1. And then you want to combine your like terms. So subtract the x squared, add the 3x, and subtract the 1. So 0 equals x to the third minus 4x squared plus 3x, and then this is gone. So from here, you can factor out the x. And then the factors of positive 3 that sum to negative 4 would be negative 1 and negative 3. Split and solve this, and I actually get 3x values. X is 0 is the first one. X is 1 would be second in order. And the third would be x is 3. So then you got to take and plug each of those back in. So if I take and plug it in, let's say I just plug it into the bottom one. Y equals x squared minus 3x plus 1. If I make these 0, 0 minus 3 times 0 plus 1, y is 1. So that's the first coordinate point. If I make them 1, it's negative 1. And if I make it 3, 9 minus 9 plus 1 is 1. And then the graph, I mean, that's pretty much what we're going to, tomorrow we're going to talk about like how I would actually graph that by hand and then get a solution from it. But when you graph, you're not going to have an x to the third on the graphs, but if you did, if you were to graph this, then everywhere these two intersect are solution points, and those should overlap with what you found. Other questions from the homework before we get into elimination? Okay, so obviously I think if given the choice, most people would choose elimination. I would say that there are times when it's already isolated, like a variable is already isolated in one of the equations where it would probably be easier to use substitution, but really you get to have the choice. So a lot of times it will just say solve and you get the choice. Sometimes it's going to say solve using elimination, so you're going to have to know how to use elimination. It's going to say solve using graphing, and then you're going to need, so you need to know how to do all three, but then there's going to be times in which you get to choose, okay? So elimination, which is also called addition in some books. So depending on where you took algebra, this also is known as addition because you're adding two equations together. But the goal here is to line up the x, the y's, and the constants. Usually it's the x's, then the y's, and the constants. Doesn't have to be that way. It doesn't even have to just be x's and y's. It could be any kind of variables. But you want to line them up. Usually the constants are on the other side of the equal sign. If you need to, you're going to either change one or both of the equations if you need to, so that when you combine these or you add these equations, one of the variables cancels out. Then you're going to combine the equations. One variable is going to remain. You're going to solve for that variable, and then you're going to take and plug that back into either of the original equations to solve the remaining variable. Just like with substitution, there are two special cases. If both variables cancel out and the statement is false, it's a no solution. If both variables cancel out and the statement is true, it is all real numbers. So false being like a 0 equals 1, obviously that's not a true statement. True being like a 0 equals 0. That would result in your all real numbers. All right, let's work through them. So number 1, 3x plus 2y equals 4, and then 5x minus 2y equals 12. First thing is make sure they're in line. Both the x's line up with the y's with the constants. And then if I were to add these two, do they cancel out? Or does a variable cancel out? Yes, so I don't even have to change anything. I'm just going to add them. This would be 8x, these cancel, equals 16. Divide both sides by 8. X equals 2. Sure. And then you can take that and plug that back into either of the equations. So I could bring it back in and plug it into the top or to the second one. 3 times 2 plus 2y equals 4. 6 plus 2y equals 4. Subtract the 6. 2y equals negative 2. Divide both sides by 2. And y equals negative 1. And then just like the solutions from yesterday, they'll go in ordered pair x then y. We remember elimination, right? How many of you, if given the choice, choose elimination usually? Okay. How many of you choose substitution? Okay. The other, you guys going to have to make a choice at some point. I would say know how to bounce back and forth because sometimes it's going to be easier to be set up one way or the other. All right. 2. Do I have to change them before I add them? Nope. I can just add. Will it say what? Like it will definitely force you into at least graphing, but I think the other two you're going to get the choice between. No, you have one more after this. Yeah. All right, so we have 4x, these cancel, equals 3, and then divide both sides by 4, and x equals 3/4. Then I'm going to take and plug that back in, and again, it can get plugged up into either one. If I just grab the first one, 2 times 3/4 plus y equals 4. You can either multiply by 4, get rid of it, or you can simplify 3/2 plus y equals 4, subtract the 3/2. 8/2 minus 3/2, and y is 5/2. You will keep these exact. You can keep them as simplified fractions. And just like with substitution, these can all be checked, right? I can take those and plug them back in and they can get, and check to make sure the left side would equal the right. All right, so now we get to 3. 3 again, they're lined up. The x's and the y's are lined up, but this time if I add them, they do not already cancel out, which means I've got one extra step here. I want to get them to cancel, okay? You can totally cancel the x's. I can multiply the top by a -5 and the bottom by 2 and cancel out my x's. Or I can go to the y's. The y's are already opposite signs, and one is like a multiple of the other. So obviously it's easier. If I could just multiply this by 4, then it's going to cancel out the y's. So I'm going to rewrite this. 2x minus 4y equals -7. And then 20x plus 4y equals -4. Add these, 22x, these cancel, equals -11. Divide both sides by 22. And x is -1/2. Now take them and plug them back in. And you can plug it back into either original. You could even plug it back into the one you changed. It's just that there's going to be coefficients there that I would avoid if I could. Not that one, sorry. The one you changed, which was here. You could even plug it in there. I would say probably just grab the second one because the y is by itself. So 5x plus y equals -1. 5 times -1/2 plus y equals -1. negative 5 halves plus y equals negative 1. Add the 5 halves. Y equals, this is 2 over 2, so that's 3 halves. And then I got negative 1 half and positive 3 halves. You could have also like plugged in here and the variables would have canceled, like the 2, I mean not the variables. The 2 would have gone into the fraction of the half. It would end up coming back at the end when you divide by 4. But it could eliminate it temporarily if you wanted to. You could plug it back into either one. Good so far. Questions on that one? Yeah. 3 is negative a half and 3 halves. All right. All right, so now when you get to 5 and 6, you can't just change one of them, right? You have to change both. So you have a choice with 5. I would either say multiply the top by 5, the top by 2 and the bottom by 5. One of them has to be negative to cancel the x's. Or go with the y's. The only reason I would recommend the y's are because one is already negative. And we all know that like, no matter how smart you guys are, you tend to screw up the negatives. So if you can avoid changing the signs, I would say go that route. Doesn't mean it's wrong to go the other route, but if you can avoid changing the signs, go that route. Which means you would cancel out the y's here. So I would multiply this by 4 and this by 3. So I'd get 20x plus 12y equals 36. And then I'd get 6x minus 12y equals 42. Combine your rows. This would be 26x. This cancels, which was the goal there, equals 78. Did I do that right? Yeah. And then divide both sides by 26. So you can go 13, 39, and that's 3. Then take it and plug it back in. You can plug it back into any of the originals or the one you change. It doesn't matter where you plug it back in, but if I plug it back in here, 2 times 3 minus 4y equals 14. 6 minus 4y equals 14. Negative 4y equals 8. And y equals negative 2. So 3, negative 2 should be your solution. And again, with extra time, you can always check these, take and plug them back and make sure they work. Questions on that one? Raise your hand if you got it right. Good. All right, 6. Now you have like no opposite signs. So it doesn't matter, you're going to have to change one or the other. How many of you canceled out the x's? How many of you canceled out the y's? Okay. So if you did the x's, you could have done negative 2 and positive 3. If you did the y's, same with the 5 and the 2. One would be positive, one would be negative. This is negative 6x minus 4y equals negative 14. And then 6x plus 15y equals 3. Cancels here. 11y equals negative 13. I can't read my own handwriting. Negative 11. And then divide both sides by 11. And y equals negative 1. Take it, plug it back in. So I'm going to plug it back into the top. 3x plus 2 times negative 1 equals 7. 3x equals 9. And x equals 3. Questions on that one? Okay, so then you're going to get to things like 7 where they've both got decimals in them. You can choose, and they don't even both have to have decimals. You can choose to eliminate them by getting rid of the decimals and then finding the least common denominator or least common multiple, or you can keep the decimals. It's completely up to you. Obviously, if you're going to change it, you don't have to change both. So like if I wanted to multiply this by 100 and this by 10, you totally can if that's what works. or multiply one and not the other. It's not required. But at some point, you're going to have to cancel out those variables. So if I were to multiply this by 100, I end up with 2x minus 5y equals, don't forget to go across the equal sign as well to move that one. And then multiply by 100 here, and I'd get 3x plus 4y equals 104. Now, how many of you canceled out, or how many would cancel out the x's? How many of you cancel the y's? Okay, because the y's are opposite signs. We can multiply this by 5, multiply this by 4, and I'd get 8x minus 20y equals 152, negative 152. And then the bottom, 15x plus 20y equals 520. Add these, 23x equals 520. I'll cheat just for time. 520 minus 152, you get 368. Divide that by 23, and x is 16. So this is a scenario in which I would say it's probably easier to plug them in after you got rid of the decimals. You can take that and plug it back into either of these equations, but you can also choose to use one of these. So if I were to grab this one, 2 times 16 minus 5y equals negative 38. 32 minus 5y equals negative 38. Subtract the 32. Negative 5y equals negative 70. Divide by negative 5. And y is 16. So you do not have to plug it back into the original. You can plug it back in after you multiply by 100. Shoot, you can plug it back in after you made it into the purple ones. It doesn't matter where you plug it back in. You should always get the same y. Yes. 14, 16, 14. Thank you. Questions on that one? Yeah. No. Yeah. I don't, they're not that bad. I mean, we started to build it, but we haven't finished it. But they're not that bad yet. Yeah. All right, 8. Again, canceling out this time. If I multiply, let's say I multiply the top by 2 to get rid of the x. 2x minus 4y equals 6. When I combine these, I end up with 0 equals 7. Is that a true statement? No. So this was your no solution scenario. If they both canceled and you ended up with 0 equals 0, that's all real numbers. But if you cancel and you're left with a false statement, obviously 0 does not equal 7, that's when you get no solution.
Would that be parallel lines and graph?
Correct.
We have to graph that later.
Not yet. Yeah, we'll just save that for tomorrow. Yeah.
What if, like, you multiplied both by, like, what if you multiplied the second one by, like, 4, and then the first one by
4.
The second one by 2.
So you'd get 4x minus 8y equals 12. And then this one by 2, you're saying? Mm-hmm. Negative 4x plus 8y equals 2. So these still end up canceling out. You'll get a different false statement, but it's still false. So if it doesn't matter how you change it, if it was in no solution to begin with, it will stay no solution. It will be a different, like that is a completely obviously different answer as the 0 equals, but it's still false. You're welcome. All right, last slide, and then we'll call it quits for the day. All right, so for the first one, it doesn't matter which one you start to cancel out. If you're going to multiply by 2 for the x, it also would change of the y. It's going to cancel, so this would be 12x minus 10y equals 6. These cancel and cancel. Again, you get the 0. This time it equals 11. Not true, so this is no solution. I think on WebAssign you literally type in the words no solution with no space if that happens. For 10, same thing. If I multiply everything by 2, well, I'd have to do negative 2, so it cancel out. Negative 4x plus 2y equals negative 2. And this time I cancel, I get 0. But this time also cancels on the other side of the equal sign. And a 0 equals 0 is all real numbers. And the last one, to get rid of those fractions, I can multiply everything by the least common denominator, or 8. So 2 goes into 8 4 times. This would be 4x. 8 and 8 cancel, minus y. 8 and 8 cancel, and I get equals negative 3. And then negative 4 plus y equals 3, and this cancels and cancels and cancels again. So it's all real numbers.
What would happen if like they didn't all have a common denominator?
So you would just find it, right? Like, so if it was like 2 and 5, I'd multiply everything by 10. Yep, just whatever you can find. So we're going to stop here. We'll do the graphing tomorrow, and we'll do those last examples on the first set of notes using elimination. There's one I'm going to do substitution, but the other ones we'll do elimination. But for tonight's homework, so I published it. It's not due till Thursday again, but you can do 1 through 8, 9 and 10 of the graphing if you want to hold off on those. 11 says use any method, I think. Yeah, 11 says use any method, so you can choose between elimination and substitution. And 12 is a word problem, which now you can either choose between substitution or elimination. You get to choose, okay? I would say for 1 through 8, try to stick with elimination for this section so you could practice it. And then after that, you can kind of pick between whichever ones you want.